Hi everyone, myself Anirban, welcoming all of you to beta classes. So in this lecture we are going to learn about speed and velocity. In the previous lecture we have learned about distance and displacement. If you haven't watched that video, please go and watch. So the first question is, what is speed and velocity? So speed is equal to total distance divided by total time. Speed is equal to total distance divided by total time, and velocity, that is equal to displacement divided by time. So in the last lecture we have learned about distance and displacement. So in this diagram, from position A to position B, this path is the distance, and if I go from point A to point B such a straight line path, that is your displacement. So speed is equal to total distance by total time, and velocity, that is equal to displacement by time. Here speed is a scalar quantity and velocity is a vector quantity. That means speed has only magnitude and velocity has magnitude and the direction. Now, what is the meaning of average speed? Average speed is this one, total distance by total time, and average velocity means displacement by time. Okay, one important concept, that is average speed, that is always greater or equal to the modulus of average velocity. Average speed, that is always greater or equal to modulus of average velocity. What is its meaning? That means, suppose in this diagram, this is the total distance and this one is the total displacement. So we know that average speed, that is equal to total distance by total time, and average velocity, that is equal to displacement divided by time. So we know distance always greater than the displacement, and for some special cases it may be distance that is equal to displacement. For an example, suppose from point A to point B, this is the diagram and this one is the total distance and this is the displacement. So in this case distance is equal to displacement, so that is why here equal sign is used. But in all other universal cases, distance always greater from displacement. This is the distance that is greater from displacement. That is why average speed, that is always greater or equal to the modulus of average velocity. Understood? And here modulus sign is used because velocity is a vector quantity, and we know that vector quantity has magnitude and direction. So it may be, the direction may be positive or negative. So that is why here a modulus sign is used to represent the magnitude only. That is, so average speed always greater or equal to the modulus of average velocity. So that's all for average speed and average velocity. Now let's have a look on instantaneous speed and velocity. So instantaneous means at a particular time or a small interval of distance or displacement or time, such a kind way we can write here as, suppose this is from point A to point B, this is a distance, okay, and suppose this one is a distance. The total distance we can consider it as x, so it will be dx. So this one is a very small distance or very small path. So at that time or at this region, the velocity or speed is considered as instantaneous speed or instantaneous velocity. Understood? So instantaneous speed or instantaneous velocity, that is, instantaneous speed and velocity are defined at a particular instant and are given by v is equal to limit del t tends to 0 del s divided by del t, that is equal to ds by dt. Okay, and v, that is equal to limit del t tends to 0 del r by del t, that is equal to dr by dt. Okay, so this is a concept of limit. This is not so much important. You have to remember one thing, that is velocity or displacement, velocity, that is equal to dx by dt. That means here x is a function of t and you have to differentiate this function with respect to time and you will get the velocity. And we know that velocity is the vector quantity and it has the magnitude and direction. So if we take modulus of velocity, we will get the speed. Okay, so this is time to solve some numericals. Question number 1 is, here is a farmer at point A and he goes to north direction approx 500 meter and then he goes to the east direction 400 meter and then to the south direction 200 meter. Now you have to calculate his average speed and average velocity. So the farmer has reached, suppose the farmer has reached to the point B. Okay, so we know that average speed, that is equal to total distance by total time. So total distance divided by total time. Okay, so total distance by total time. So the total distance is 500 plus 400 plus 200. So it is equal to 900, 1000 and 1100. So it is 1100 meter and the farmer takes 20 minutes to reach from A to B. Okay, this is the time. So you have to convert it in seconds, so it will be 20 into 60, 1200 seconds. So the average speed, that is equal to total distance is 1100 meter divided by second, so 1200 seconds. So 0 cancel, so 11 by 12 meter per second, this is the average speed. Now average velocity, that is equal to displacement by time. Now you have to calculate the displacement. Okay, so look at the image. This one is the displacement, the direct connection from A to B. So you have to calculate this AB length. So it will be, as this is 400 meters, so this part is also 400 meter and this one is your 200 meters, so this is also 200 meter. So this part is 500 minus 200 meter, that is your 300 meter. So according to the Pythagoras theorem, AB square, that is equal to this one square plus this one square. So 300 square plus 400 square. So AB square, that is equal to 90000 plus 160000. So it will be 250000 and root under. So this is your AB. So it is equal to 5 and 00 meter. So this is your 500 meter. So the distance AB is 500 meter. So this is the displacement. So average velocity, that is equal to displacement by time. So that is equal to displacement is your 500 divided by time is 1200 second. So 0 cancel. So 5 by 12 meter per second. This is your average velocity. Okay, so average speed is 11 by 12 meter per second and average velocity is your 5 by 12 meter per second. Question number 2 is, here is velocity which is written as 2i cap minus 3j cap plus 4k cap. Okay, this one is your instantaneous velocity in a 3-dimensional space. Then you have to calculate the instantaneous speed of the particle at this instant. So we know that instantaneous speed, that is equal to the modulus of instantaneous velocity. Instantaneous speed, that is equal to modulus of instantaneous velocity. Fine. So this one is your instantaneous velocity and you have to calculate the instantaneous speed. So if we take this vector's mod or modulus value, we will get instantaneous speed. So simply root under 2 square plus minus 3 square plus 4 square. So 16 plus 4 20 plus 9 29. So root under 29 meter per second. This is your instantaneous speed. The third numerical is, a particle is moving along x-axis. Okay, a particle, here is a particle, it is moving along the x-axis. Its x coordinate varies with time as x equal to 2t square minus 4. So here x is in meter and t is in second. So the question number 1 is average velocity. Okay, average velocity of the particle in a time interval from t equal to 0 to t equal to 4 second. And question number 2 is the instantaneous velocity instantaneous of the particle at t equal to 1 second. Okay, so in the question number 1, here is average velocity, and average velocity, that is equal to average velocity, that is equal to displacement by time. Okay, so displacement by time. So displacement is the final position minus the initial position. So the final position minus the initial position divided by total time, or we can say it as the final by at the last time. Okay, the last time t final minus t initial. So in this equation, if we put t equal to 0, we will get the initial position of the particle, and if we put t equal to 4, we will get the final position of the particle. So x equal to x final, that is equal to 2, so 4 square minus 4 square 16 into 2 32 minus 4, so 28. So it is your xf, and x initial, that is equal to, put t equal to 0, so it will be minus 4. Okay, so it is equal to 28 minus of minus 4 divided by the total time taken, that is your 4 second, minus 0, so 28 plus 4 by 4, so 32 by 4, 8 meter per second. Okay, this is the answer of question number A, the average velocity. And instantaneous velocity is dx by dt. Here x, I have told that x is the function of time, and this is the function of time, and if we differentiate this function with respect to time, okay, we will get the velocity, we will get the instantaneous velocity. So that is equal to ddt of 2t square minus 4, so 4t, okay, and put t equal to 1 second. Okay, put t equal to 1 second here, so it will be 4 into 1, so 4 meter per second. Okay, this is your instantaneous velocity. Okay, this is your instantaneous velocity. So that's all for today's lecture. Hope you have understood very well about the concept of average velocity, average speed, instantaneous speed, and instantaneous velocity. Practice different kinds of numericals from your own side. So see you in the next lecture. Take care. Goodbye.